So today in this video we will discuss about the charged particles which are moving in a uniform magnetic field and what will be the shape of the path of those charged particles. Okay. So first of all, case number 1. So in case number 1 it is given that when motion of charged particle is parallel or anti-parallel to the uniform field. Parallel or anti-parallel means, suppose the thing is like this. This is the direction of magnetic field B. Okay. Say I am showing it here on this one. B is the direction of magnetic field, this side. Okay, B. Now a particle, a charged particle, suppose this one, it is allowed to enter in this region in the same direction with the magnetic field. So this is the direction of velocity of the particle V. So what is the angle between V and B? Since it is in the same direction, angle theta is how much? 0 degree. If theta is 0 degree, we have the formula for magnetic force, F is equals to Q into V cross B, right? That was the formula. So if you just open this bracket and this one for cross product, what we can write? Q V B, then sin theta. So in this case theta is how much? 0 degree. So sin 0, if you substitute, the force becomes what? 0 only. So that means if the particle enters in a magnetic field in parallel way or it may be anti-parallel also, means if this is the direction of magnetic field B and if the particle enters this way V, then the angle between V and B will be 180 degree. In that same formula QVB sin theta, if you substitute 180 degree in place of theta, then also the value of force will be 0. Okay, so that's what is written, that for 0 degree means for parallel, for 180 degree that means for anti-parallel, the force Fm or F whatever you write, that will be 0. This is case number 1. Case number 2 is very important and interesting also. You have to understand this part. Case number 2. Okay. Fine. So see here, what kind of magnetic field is this? I told you, if it is cross, that means the magnetic, see the whole region is given by some cross. Cross means the magnetic field is into the plane of the paper. Okay, the magnetic field is into the, it is going inside the plane of the paper. Okay, the particle is released in this direction, this one. See it here. Okay, this part. The particle is released in this direction. So can we say here that the direction of B and V are perpendicular to each other, means the angle is 90 degree. Perpendicular, because B is into the plane of the paper and V is like this. Okay, so they are perpendicular. Now if they are perpendicular, the thing is like this. Okay, I am just suppose this is the direction, just a second, this is the direction of V and B is into the plane, so I am showing it like this, into the plane of the paper. Since it is 3-dimensional case, difficult to show. This is B, this is V. Angle is how much? You have to imagine, okay, this angle is how much? 90 degree. Alright. So if it is 90 degree, what will be the direction of force? Direction of force, what it will be? This is V, this is B. Direction of force will be perpendicular to the plane containing V and B. You know this one. And how to find out the direction? With right hand rule. What you have to imagine, that the V is moving towards B because it is V cross B. In last video I told you, if V is moving towards B, the force is like this side. Suppose if this is y axis, V is along y axis, if B is along z axis, then force should be along which side? X axis. V is moving towards B, curl of the 4 fingers should be like this, of your right hand should be like this, then the force goes this side, You try it and see the force goes this side. Okay, so here it is shown in the figure. This is the force goes this side. So if what kind of force is that? It is a magnetic force, and the value of this force will be how much? We have the formula, F is equal to q into v cross b, or we write vb sine theta. So in this case theta is 90 degree, so sine 90 is 1, so the force is qvb. This is the magnetic force which is acting on this particle in this direction. Now due to this force which is acting in this direction, what happened is the particle initially it was going like this, but due to this pull from this side, the particle will deviate from its path and it goes like this due to this force. The force is pulling it, so it has an initial velocity like this, right? So directly exactly it will not come this side, but it will deviate from its path like this. And as the particle reaches to this position, then what will happen? Here in this, at this position, the direction of its velocity is this side. Magnetic field is into the plane. This time this is velocity. Magnetic field is like z axis only, this one. This is v, this is b. Force in which direction? V cross b, if you do this direction, this is the direction of force. Now due to this force, again the particle was going like this, but due to this force again it will deviate. It goes like this. And as the particle reaches to this point, its velocity is this side, b is as usual, so force will be again this side. So it was going like this, it was going like this in this direction, it will again deviate. So ultimately you can see that the particle is moving a circular path like this. So if it is moving a circular path, see, all these forces at each and every point is pointing towards the center of the circular path. If the force is pointing towards the center of the circular path, can we call it centripetal force? We can call it centripetal force. What was the magnitude of the force? Just now I told you, F, since 90 degrees is the angle, the force is qvb. But this force is also equal to what? Centripetal force. So can we write this is also equal to mv square by r? So this is the equation from which we will derive some other equation also. So remember that very important part, that if the particle enters in a magnetic field like this is the direction of velocity, magnetic field is into the plane of the paper, angle is 90 degree between v and b, the particle will follow a circular path. Okay, now we will derive some equations. Okay, so this part or whatever is written here already I told you, you can just go through, you can read once. So what I said, I'll start from this equation. How we got this? qvb, the force, magnetic force, which is equal to how much? mv square by r, right? So from this part, see here, r will be equal to this one. So this is the expression for radius of the circular path. R means what? Radius of the circular path. This is one formula. Okay, we can write it in this way also, so that in some questions there may be given the q by m ratio, charge by mass ratio. If it is given, directly we can substitute the value here. Okay, or else you can use this one also, not a problem. So from this equation also you can derive the expression for v. How to get that? If r equals to mv by qb, v means velocity will be equal to how much? This qb will go that side with r, so it will be r qb by how much? M, no? This is the expression for velocity, r qb by m. This will be used in the next page. Okay, so one expression we got for radius, one expression we got for velocity. Whatever I wrote just now for velocity, you can write down also. Okay, then we will find kinetic energy of the particle. The particle is moving on some circular path, so it will have some kinetic energy. We have the formula, half mv square. So half m will remain as it is. The formula for v just now I told you, qbr by m. Substitute it, square it, since it is v square, this is the value. Okay, one mass 1 mass, here it is m square, so 1 mass will get cancelled, it will be 2m. This 2 and then this m. Alright. So this is the expression for kinetic energy. Remember these expressions. Then time period. Time period t is equal to, we know it is distance by velocity or speed. So distance, since it is going in circular path, the distance is nothing but the circumference of the circle, which is 2 pi r. Speed is v, suppose. Now the expression for v in last page already I told you. Okay, so you can substitute the value, that's all. 2 pi r will remain. The value of radius also we got in the last page, velocity also we got, so you just substitute these values. See, radius is substituted here. Once the radius is substituted, velocity no need. Okay, you substitute any one value, either you substitute for velocity or you substitute for radius. So what they have done here, they have substituted for radius, and so that velocity get cancelled. Okay, so better you do that only. Radius you substitute. How, from where? From here. Okay, mv by qb, that was radius. So if you substitute here mv by qb in place of this r, how much you are getting? This value. So if this is the time period, what is the frequency? Frequency is the reciprocal of time period, so you just reverse it, qb by 2 pi m. Okay, done. Next, after this expression, next will be angular frequency omega. You have this value, you got it in class 11. Omega means 2 pi nu. Nu is the frequency, so 2 pi will remain as it is, the value of frequency. You substitute this value here, you will get qb by m. This is the angular frequency. This angular frequency is also called gyro frequency. Remember these terms. Okay, now here you will get one device, the name of a device, that is cyclotron, which basically based on this principle. This principle means when a charged particle enters in a magnetic field in a perpendicular direction to the field, then the charged particle undergoes circular motion. That is the principle of cyclotron, but this time in your syllabus the cyclotron part is omitted, so this one is not required. Just you can remember this part, that cyclotron, it is a device, we call it accelerator. This is a accelerator, it accelerates the charged particles. Cyclotron accelerates the charged particle, and it works under which principle? That when a charged particle enters in a magnetic field in a perpendicular direction, then that particle undergoes a circular motion. This is the principle of cyclotron. Okay, so two cases we discussed. One is when the angle is 0 degree or 180 degree. Second one when the angle is 90 degree. Third case is when the angle is having some acute value, means less than 90, more than 0. So for that, what is the shape of the path, that one we will discuss in next video.